In 2008, NASA scientists discovered something that should not exist. They watched as entire galaxies, thousands of them, were being pulled in the same direction. Not randomly. Not chaotically. Together. In perfect unison. Toward something invisible. Something we cannot see. Something we cannot measure. Something beyond the edge of our observable universe. And here is what keeps astronomers awake at night. Whatever is pulling them is so massive, so impossibly large, that it bends the very fabric of space itself. They called it dark flow. And 14 years later, we still have no idea what it is. Let me take you there. You know that feeling when you are standing at the edge of the ocean at night? The water is black. The horizon disappears into nothing. You can hear the waves, but you cannot see what is making them. You feel small. Impossibly small. That is exactly how I felt when I first learned about this phenomenon. We like to think we understand space. We have mapped galaxies. We have photographed black holes. We have sent robots to Mars and probes beyond our solar system. But the truth is, we only see about 4% of what actually exists in the universe. The rest is darkness. The rest is mystery. And somewhere out there, in that darkness, something is moving. Something so large that our entire observable universe might just be a tiny ripple in its wake. Let me explain what we actually know. Picture our galaxy, the Milky Way. It is about 100,000 light-years across. That is unimaginably vast. Light itself, traveling at 300,000 kilometers per second, takes 100,000 years to cross from one side to the other. Now zoom out. Our galaxy is part of a group called the local group. About 80 galaxies clustered together, orbiting around a common center of gravity. Zoom out further. The local group is part of the Virgo Supercluster. Thousands of galaxies spanning 110 million light-years. Zoom out even more. The Virgo Supercluster is just one small tendril of something called Laniakea. This is our cosmic address. A supercluster of superclusters containing over 100,000 galaxies. And all of it, every single galaxy, every supercluster, every void and filament of cosmic web, is moving. Moving toward something we cannot see. In 1973, astronomers noticed something strange. Galaxies in our cosmic neighborhood were not moving the way they should. According to our models, after the Big Bang, matter should be spreading outward in all directions. More or less uniformly. Yes, there would be some local gravitational attractions, but on large scales, everything should be expanding evenly. That is not what we found. Instead, we discovered that our entire local group, along with thousands of other galaxies, was being pulled toward a specific point in space. The speed was astonishing. 600 kilometers per second. That is 2.2 million kilometers per hour. And the direction was always the same. Toward a region in the sky in the direction of the constellations Centaurus and Hydra. Scientists called this mysterious region the Great Attractor. Now, here is where it gets unsettling. We cannot actually see the Great Attractor directly. Why? Because it sits directly behind the plane of our own galaxy. The Milky Way's disk is filled with dust, stars, and cosmic debris that blocks our view. Astronomers call this the zone of avoidance. Think about that for a moment. Something is pulling us through space at millions of kilometers per hour, and we cannot even see what it is because our own galaxy is in the way. It is like being dragged towards something in the darkness, but every time you try to turn your head to look, your own shoulder blocks your vision. For decades, this was one of the biggest mysteries in cosmology. What could possibly be massive enough to pull entire galaxy clusters toward it? In the 1990s, we got some answers. Using X-ray telescopes and infrared observations that could penetrate the dust, astronomers mapped the region behind the zone of avoidance. What they found was impressive, but also strangely unsatisfying. Yes, there were large structures there. The Norma cluster. The Centaurus supercluster. Massive concentrations of galaxies. But here was the problem. When they added up all the visible mass in that region, it was not nearly enough to account for the gravitational pull we were experiencing. Something else was there. Something we could not detect. And then, in 2008, everything changed. Alexander Kashlinsky was a Russian-American astrophysicist working at NASA's Goddard Space Flight Center. He was studying something called the kinetic Sunyaev-Zeldovich effect. Without getting too technical, this is a way of measuring how fast galaxy clusters are moving by looking at tiny distortions in the cosmic microwave background radiation. The cosmic microwave background, or CMB, is the afterglow of the Big Bang. It is the oldest light in the universe, released about 380,000 years after the Big Bang when the universe cooled enough for atoms to form. This light is everywhere. It fills all of space. And by studying it very carefully, we can detect how galaxy clusters are moving through it. Kashlinsky and his team looked at over 700 galaxy clusters. These were not small objects. Each cluster contained hundreds or thousands of galaxies. And what they found defied explanation. All of these clusters, spread across billions of light-years, were moving in the same direction. Not just our local neighborhood. Not just the galaxies near the Great Attractor. Clusters that were 3 billion light-years away from us were moving the same way. The speed was roughly 1,000 kilometers per second. Toward a point in the southern sky. But here was the truly disturbing part. When they traced the direction of this motion, it did not point toward the Great Attractor. It pointed beyond it. Far beyond it. It pointed toward something outside our observable universe. Let me help you understand why this is so significant. Our observable universe is not the whole universe. It is simply the part we can see. Light has a speed limit. And the universe has an age. It is about 13.8 billion years old. This means the farthest we can possibly see is about 46.5 billion light-years in any direction. That is our cosmic horizon. Beyond that, light has not had enough time to reach us since the Big Bang. We have no idea what exists beyond that horizon. It could be more of the same. It could be something completely different. It could be infinite nothingness. But whatever is out there, it should not be able to affect us. According to our understanding of physics, nothing beyond the cosmic horizon should have any gravitational influence on our observable universe. The information simply cannot travel faster than light. Yet Kashlinsky's data suggested exactly that. Something beyond the edge of everything we can see was reaching across that boundary and pulling matter toward it. He called it dark flow. And the scientific community was divided. Some researchers tried to replicate his findings. Some succeeded. Others failed. The controversy raged for years. In 2013, the European Space Agency's Planck satellite released new data on the cosmic microwave background with unprecedented precision. The Planck team analyzed the same effect Kashlinsky had studied. Their conclusion was cautious but troubling. They found no definitive evidence of dark flow at the largest scales. But they also could not rule it out entirely. The signal was there, just at the edge of statistical significance. What did that mean? It meant we were right at the boundary of what our instruments could detect. Whatever was causing this motion, if it was real, was operating at scales so vast that even our most advanced technology could barely glimpse it. And here is what really bothered scientists. If dark flow is real, it challenges some of our most fundamental assumptions about the universe. One of the core principles of cosmology is called the cosmological principle. It states that on large enough scales, the universe looks the same in every direction and is the same at every location. No special places. No preferred directions. Dark flow violates this. If matter is flowing toward a specific point beyond our cosmic horizon, then there is a preferred direction. There is something special about that region of space. And that opens up some deeply unsettling possibilities. Let me share one theory that keeps me up at night. Some physicists have suggested that dark flow might be evidence of something called pre-Big Bang structure. Here is the idea. What if our Big Bang was not the beginning of everything? What if it was a local event in a much larger multiverse? What if, before our universe exploded into existence, there were already massive structures in place? Concentrations of matter and energy that predate our cosmic horizon? If such structures existed, they could be embedded in the fabric of space itself. They would be beyond our observable universe, but their gravitational influence could reach across that boundary. We would see their effects without ever being able to see them directly. It would be like being inside a house and feeling the pull of a hurricane outside. You cannot see the hurricane, but you can feel it. This is speculative, of course. Highly speculative. But the data is real. The motion is real. And we still do not have a satisfying explanation. In 2017, astronomers discovered something that added another layer to this mystery. They found evidence of a cosmic void on the opposite side of the sky from the Great Attractor. They called it the Dipole Repeller. Imagine you are standing on a hill. On one side, there is a deep valley pulling you down. On the other side, there is nothing. Empty space. You would roll toward the valley, right? But what if, on the other side, instead of just empty space, there was a force actively pushing you away? That is what the dipole repeller appears to be. It is not just an absence of matter. It seems to be a region of space that is actively pushing galaxies away from it. So we have the Great Attractor pulling us from one direction and the dipole repeller pushing us from the opposite direction. Two cosmic forces working together to drive our galaxy and billions of others through space at unimaginable speeds. And we still do not fully understand either of them. Let me tell you about the Shapley Supercluster. This is what we think lies behind the Great Attractor. It is one of the most massive structures in the observable universe. The Shapley Supercluster contains thousands of galaxies. Its total mass is estimated at about 10 million billion solar masses. That is a number so large it becomes meaningless. Let me put it in perspective. If every human on Earth counted one number per second, it would take us longer than the current age of the universe to count to that number. The Shapley Supercluster is about 650 million light-years away from us. We are falling toward it at hundreds of kilometers per second. In about 4 billion years, our local group might begin merging with it. By then, of course, our sun will be nearing the end of its life, and Earth will be a scorched remnant of what it once was. But here is the strange part. Even the Shapley Supercluster is moving. The whole thing, all 10 million billion solar masses of it, is also being pulled in the same direction as everything else. So it is not the source of dark flow. It is a victim of it. Whatever is pulling everything is even more massive than the Shapley Supercluster. And that is terrifying. In 2022, new research suggested that we might have been looking at this problem wrong. A team of scientists proposed that the motion we observe might not be caused by a pull at all. It might be caused by a fundamental asymmetry in the expansion of the universe itself. According to this theory, the universe might not be expanding uniformly in all directions. Some regions might be expanding faster than others. This would create the illusion of motion toward a specific point, even if there was nothing actually pulling us there. Think of it like standing on a stretching rubber sheet. If one part of the sheet stretches faster than another, you would drift in that direction without anything physically pulling you. This theory is elegant. It explains the observations without requiring mysterious masses beyond our cosmic horizon. But it comes with its own problems. If the universe is not expanding uniformly, then our entire model of cosmology needs to be revised. The equations we use to calculate the age of the universe, the distance to far galaxies, the nature of dark energy, all of it would need to be reconsidered. One mystery would be solved, but 100 new ones would emerge. I want to take you deeper into what this means for us as a species. We are not just observers in this cosmic drama. We are participants. Right now, as you read these words, you are moving through space at roughly 600 kilometers per second toward the Great Attractor. You do not feel it. You cannot perceive it. But it is happening. The Earth is orbiting the Sun at 30 kilometers per second. The Sun is orbiting the center of the Milky Way at 230 kilometers per second. The Milky Way is falling toward the Andromeda Galaxy at 110 kilometers per second. And all of it, our entire cosmic neighborhood, is being swept along by something we cannot see. Every second, you travel about 600 kilometers closer to whatever is out there. In the time it took you to read this sentence, you moved about 3,000 kilometers through intergalactic space. And you did not feel a thing. That is the strange beauty of the universe. We are embedded in motions so vast, so profound, that our entire lives pass without us ever perceiving them. We are like ants on a log floating down a river that is falling over a waterfall that is on a planet that is hurtling through an endless void. And we think we are standing still. There is another possibility I want to share with you. What if dark flow is not being caused by a massive structure at all? What if it is being caused by another universe? The multiverse theory suggests that our universe might be just one of many. Perhaps an infinite number. These universes might exist in higher dimensional space, separated from each other but occasionally interacting. Some physicists have proposed that dark flow might be the gravitational influence of a neighboring universe brushing against our own. Imagine two soap bubbles floating next to each other. They are separate, but where they get close, they deform slightly. Their surfaces bend toward each other. If another universe existed near ours, its gravity might reach across the boundary between realities and tug at our matter. We would see its effects without ever being able to observe it directly. This is wild speculation, of course. We have no evidence of other universes. We may never be able to obtain such evidence. But the fact that serious physicists are willing to consider such possibilities tells you how strange and unexplained this phenomenon really is. Let me share some hard numbers with you. The velocity of dark flow, as measured by Kashlinsky's team, is approximately 600 to 1,000 kilometers per second. The motion has been detected in galaxy clusters as far as 3 billion light-years away. The direction is consistent across all of these clusters, pointing toward a region in the southern celestial hemisphere. The mass required to cause such motion, if it is a gravitational pull, would have to be at least 10 to the power of 18 solar masses. That is a billion suns. Our entire observable universe contains roughly 10 to the power of 24 stars. So we are talking about a structure that contains a significant fraction of the mass of everything we can see. And yet it is invisible to us. Hidden beyond the cosmic horizon. It is like knowing there is a mountain in a fog, not because you can see it, but because all the birds are flying toward it. I want to address something important. When we talk about cosmic motion and galaxies falling through space, it is easy to feel a sense of doom. A sense that we are helpless, caught in forces beyond our control. And in a way, we are. But I think there is another way to look at it. The fact that we know about dark flow, the fact that we have measured it and debated it and struggled to explain it, is a testament to human curiosity. A species on a small planet orbiting an ordinary star in the suburbs of a mid-sized galaxy has managed to detect motions happening on scales of billions of light-years. We have instruments sensitive enough to measure the faint distortions in radiation that left the Big Bang 13.8 billion years ago. We have mathematics sophisticated enough to model the behavior of matter across cosmic time. We are tiny, yes. We are brief, yes. But we are paying attention. We are asking questions. We are trying to understand. And that, to me, is the most extraordinary thing in the universe. Not the Great Attractor. Not dark flow. Not whatever mysterious force is shaping the fate of everything. The extraordinary thing is that we care enough to look. So where does this leave us? We know that something is pulling matter through space on scales of billions of light-years. We know that the source is either beyond our observable universe or involves physics we do not yet understand. We know that the Great Attractor, the Shapley Supercluster, and the Dipole Repeller are all part of this cosmic motion. And we know that we, right now, are participants in this grand migration. But we do not know why. We do not know what awaits us at the destination. We do not know if there even is a destination, or if this is an eternal journey through an infinite void. The universe keeps its secrets well. In 2024, new observations from the James Webb Space Telescope and other instruments are giving us fresh data on cosmic motion. Scientists are revisiting the dark flow controversy with better tools and more sophisticated analysis. Some are finding hints that the motion might extend even farther than we thought. Others are suggesting it might be a statistical illusion after all. The debate continues. But one thing is certain. Whatever the answer turns out to be, it will reshape our understanding of the cosmos. Either something truly massive exists beyond our horizon, or our models of cosmic expansion need fundamental revision. Either way, we are standing at the edge of a discovery that could change everything. I often think about what it must have been like for ancient humans, standing on plains under starlit skies, trying to make sense of the lights above them. They told stories. They created myths. They imagined gods and monsters and magical realms beyond the horizon. We are still doing the same thing. Only now, our stories are written in mathematics. Our myths are called theories. Our magical realms are called other universes. But the wonder is the same. The yearning to understand is the same. And the humility is the same. Because no matter how much we learn, the universe always has more mysteries waiting for us. Dark flow is just the latest in a long history of phenomena that have challenged our understanding. Dark matter. Dark energy. The nature of consciousness. The origin of life. We are surrounded by mysteries on every side. And that, I think, is exactly as it should be. Let me leave you with a thought. Somewhere out there, beyond the edge of everything we can see, there might be a structure so massive that its gravity reaches across cosmic distances to pull at our tiny galaxy. We will probably never see it directly. Light from that region will never reach us before the universe ends. But its influence is real. Its presence is felt. In a very real sense, we are connected to something we can never observe. Something that exists beyond the boundaries of our reality. And that something is shaping our fate. Every second, we move closer to it. Every moment, the invisible hand of the cosmos guides us toward a destination we cannot imagine. Is that terrifying? Perhaps. But it is also beautiful. Because it means we are part of something larger than ourselves. Something grander than our tiny lives and brief histories. We are not just observers of the universe. We are caught in its currents, swept along by its tides. We are not standing still. We are falling. And we have been falling since the beginning of time. Now I want to hear from you. What do you think is causing dark flow? Is it a structure beyond our observable universe? Is it another universe pressing against our own? Is it something even stranger, something we have not imagined yet? And here is a question that haunts me. If something is pulling us toward it, what happens when we arrive? What is waiting at the end of this cosmic journey? Leave your thoughts below. Tell me what you think. Because this is a mystery we are all part of. And maybe, just maybe, together we can find some answers. Before you go, I want to remind you of something. You are moving through space at 600 kilometers per second right now. You are falling towards something you will never see. And you are reading these words on a pale blue dot, suspended in a sunbeam, in the suburbs of one galaxy among hundreds of billions. You are impossibly small. And you are connected to everything. Remember that the next time you look up at the stars. Because they are looking back at you. And they are just as lost as we are.